This is a demonstration video for the vacuum tube analyzer that I've built just recently for testing vacuum tubes here in the workshop. This is a conventional tube tester. Many of you will be familiar with this. It's designed to give you a replace or good, that is to say a fail or pass result. Covers a wide variety of tubes, very good unit, but the vacuum tube analyzer that I've built has some distinct advantages over that, and I'll walk you through those now. The analyzer has a number of controls on the front panel. This is the power on off switch, meter selection control, which will read the anode current and the grid bias voltage over here. These two controls are a 1 volt per division selector for the grid 1 voltage, and when that's swung around all the way to here, we go over to a vernier adjustment which also adjusts the grid bias, but it does so without the steps. Over on the left here there's a low voltage supply, 1.2 to 15 volts DC. That's adjustable with simple knob control, and the HT, the 125 or 250 volt supply for the anodes, can be selected on or off using the HT control. That's simply a safety feature. Moving to the top of the unit, you can see the meter, which has been nested into the top of the power supply compartment at the rear of the chassis. The low voltage control, low voltage power supply control, gives you a nice smooth adjustment on the meter there, and when you select over to the grid 1 voltage, you can see that the vernier control gives you a nice smooth transition up to about minus 24 volts, and when you select the stepped voltages, you get 15, 10, 7, 6, 5, 4, and we can step down to resolve that a bit more clearly, 3, 2, 1, and finally 0 volts on the grids. In the centre of the front compartment there's a panel. Now this is the first of a number of panels which will be made for this unit. This one is designed specifically to operate twin triodes. Now you can see on the side here I've marked as 6SN7 or 6SL7s as the case may be, 6SC7s, and the 9-pin socket here is designed for the ECC series, or that's 12AU, 12AT, 12AX7s, those sorts of tubes, and 9-pin miniature twin triodes. So this panel is designed specifically for twin triodes, and in the future I'll be making other panels which are designed for 1940s series pentodes, 6SK7s, 6SH7s and the like. On this particular panel there's a left and right switch. Now this switch enables me to select which of the triodes within the envelope is being tested. So as I'm making a series of anode current tests, I can switch between the two triodes within the same envelope and take almost simultaneous measurements of the performance of the devices within the envelope. The procedure for testing a tube is fairly straightforward. You set the lowest voltage for the grid 1. In this case the top dead center marking on the switch is minus 5 volts. And then take a reading on the meter up here, then switch to the other triode and take another reading. Those two readings are then recorded into the Excel spreadsheet on the computer on the right. You then increment to minus 4 volts, check the left triode, the anode current, and then switch across to the right and check the anode current again. 3 volts, same procedure, left right, 2, left right, and you get the idea. Eventually you wind up with a set of data points which can be plotted on the Excel spreadsheet. Now I've just run a set of tests on two of the 6SN7 twin triodes. Tube 1, the left triode, and the right triode. These are the milliamp ratings against the grid 1 voltages. So 2.9 versus 3.1 at 5 volts, 15.4 milliamps versus 15.7 at 0 volts. I've then done a calculation of the left anode current over the right anode current, and then I've taken a mean value for that, and I've called it the symmetry rating. What's interesting about the tube 1 is that the symmetry rating comes down to 0.959. Over on tube 2, the anode currents are a bit more similar, especially in the lower part of the range, and when you do the left over right calculation, the symmetry rating comes down to 1.01. Now, as you might suspect, 1.01 is a lot closer to 1 to 1 than 0.959, which suggests that tube 2 has a higher correlation between the anode conduction of the two devices within the envelope than tube 1 does. And when you have a look at tubes 1 and tube 2 plotted side by side, you can see that tube 1, the left and right triodes track each other very closely, but there's a consistent offset. In tube 2, they track each other almost completely in the lower voltage ranges and then digress slowly as they get towards 0. Now, that might not seem very significant, but if you're trying to build a balanced modulator, or possibly a long-tailed pair for a precision audio amplifier, and you're talking about a bias point of about -4 volts, what's going to happen is tube 2 is going to give you a more precise response than tube 1 because of this subtle displacement between the two graphs. And that's what the vacuum tube analyzer is designed to uncover, how closely tubes can be matched to one another and precisely how they operate along their grid anode transfer characteristics. Now, the final thing I wanted to demonstrate about the vacuum tube analyzer is that it serves this other purpose. This bit of circuit board here is the entire transceiver subassembly for the 160 meter Comrade transceiver that I'm working on. As you can see, there's 6 tubes here, quite a lot of circuitry underneath there, and the whole panel nests quite neatly into the front compartment of the unit. Now, that makes it possible to construct prototypes, do a lot of modifications. The HT can be switched on and off, the chassis assembly can be lifted easily out of the compartment, and modifications can be made, and so on and so forth. So it's possible to basically debug an entire system without ever having to actually put it in its box. So this would then become a module which would go into the chassis of the actual radio, but only when it's ready to go in. That's a convenience thing. It can run a fair amount of power. This chassis will produce enough power to run a pair of 807s or 6146s or tubes of that size. There's a couple of amps of power available for filaments, and so the vacuum tube analyzer can be used for that purpose as well. That enables me to do construction work with high voltages much more safely. That's it. Thanks for watching. 73s to all. VK3ZVX clear.